Welcome once again to Advanced Math class. And this lesson you guys might have been able to get on your own. It's not. It's right on that borderline between they can get it and boy I really need to teach this. But I decided to go ahead and teach it just because I didn't want you to get frustrated trying to figure it out on your own. I don't think it's that hard. Okay, so don't feel like that. But it does have a couple of interesting points to it. Now they want to remind you of doing ellipses, which I think you did on your own. Now, the definition of an ellipse, this is important, is the sum of the distances between two foci, which is a plural of focus, and the point on the ellipse. And that's the official definition. The way it looks is like this, and you always have a plus sign between the x squared and the y squared. Now, these are just circles that are squished, and the A and B become your two radii, which aren't exactly radii because it's not a circle, but they kind of look like radii. Okay, that's an ellipse. A hyperbola is the absolute value of the difference of the distances between two foci and the point on the ellipse. So that's the technical definition. And this is x squared over a squared minus y squared over b squared equals 1. It looks a lot like an ellipse, but there's a negative sign. It's a subtraction instead of addition, and that makes a difference. It basically cuts the ellipse in half and flips it outward. Okay? If you're following along in your book on page 475, they give a little bit more explanation on the definition than what I have. I have challenged drawing this. Drawing the definition would take me too long without enough benefit. So they have it in the book. You're going to be more interested in how we do it, but this is the definition. Okay, from the distance from the focus to any point on the hyperbola, you subtract them. The absolute value is the same. That's the technical definition. Practically, it's an x squared and a y squared with a minus sign. So you get a flipped out circle. Okay, so x squared over a squared minus y squared over b squared equals 1. The positive term, a, is your focus, and the negative term, b, is a pseudo-focus. And the word named pseudo-focus is not in your textbook. I don't imagine it's a good math word at all, but it is there. If you solve for the x and y intercepts, if you plug in 0 for y, which gives you your x-intercept, in this particular problem, you will get a positive root, which will be a. If you plug in 0 for x, you'll get an imaginary root, which is b. So it'll be bi. And so it's an imaginary root. So the line, the curve, doesn't actually go through point B, but it serves us as another reference point that we need to solve the problem. Okay, so we're going to do x squared over 3 squared minus y squared over 2 squared equals 1. The positive term is 3, so that's the focus. The negative term is 2, so that's the pseudo-focus. Okay. Now, obviously, if they had 9 and 4, you have to know that 9 is 3 squared and 4 is 2 squared, but you guys can do that. Okay, so first thing we're going to do is to put our foci and our pseudo-foci on our graph. So that's 3 and negative 3 and 2 and negative 2. Okay, so that's our foci. The 3's are our foci. Our 2 is our pseudo-foci. Okay, now we're going to put a box around it. We're going to draw this box from making a nice rectangle through those lines. All right, now we are going to draw lines going across like that. And I just remembered, and I didn't do this in my PowerPoint, they often want you to write the equation of those lines. Those lines are very easy to do because their y-intercept is 0 and their slope is rise over run. So this would be y equals 2/3 x, okay? And y equals negative 2/3 x. So you don't have a b because it's 0, it goes through the origin, and your slope is just rise over run, which is just, in this case, 2/3. They will ask you for those equations, and I didn't put that in here anywhere. Okay, so now we've got this box. Now, we drew the lines the way we did because you draw those lines from corner to corner. It doesn't really matter. We're going to start now at the real foci, and we're going to draw a hyperbola. And there you go. They should be a little bit a smoother curve there in the middle than what they are, like at the focus, but that's as good as I can do on my computer, and probably about as good as you're going to do with your pencil also, so that's okay. Probably as good as I could have done with a marker on the whiteboard if we were here in school. So it's okay. Okay, so it's not really hard. We take our focus from the equation 3 and 2, mark those on the graph, put on the box, the rectangle, draw the diagonal lines from corner to corner, and then draw a nice smooth curve. Now, what would you have done if y had been the positive one? Okay, now this one we've just switched it. Y is positive. You see that in the equation. So that makes the 3's on the y-axis the real foci. The 2's are the pseudo foci. The 2 helps us get our box, which helps us get our diagonal lines. But then our curve is going to be from the real foci, which is on the y-axis in this case. Okay? And just to give you another one for illustration, this is the same, except the 6 is the, is the same, except that we have 6 for our real focus and 2 for our pseudo focus. And so when you draw your diagonals and then you draw your curve is much, much, much wider because your diagonals are spread out so much. In fact, I don't quite have it as far out as I should. They have a good example of this on 477. So follow your book. It gives you a lot of the information you need on how to do this. I just wanted to add to it for you because I thought it was important, maybe just to hear it as well as to read it in your book and maybe to see examples of it. Okay, I hope everything goes smoothly for you as you do hyperbolas. They're kind of fun, I think. But have fun with them and have a good day.